Good morning, good evening, good night, everyone. We're gonna explain a graphic and a problem with its resolution. And here's my team. I'm Alejandro Shufan.
I'm Omar Lamadi.
I'm Guillermo Alvarez.
And I'm Sergio Bentley.
Before we go on, we need to understand a couple of terms. So I'm gonna go ahead and tell you a couple of definitions. We're gonna start with what is a rational function. These are called rational because one is divided by the other. It's a function that is the ratio of two polynomials. How do you obtain a slanted and oblique asymptote? Well, these occur when the polynomial in the numerator is higher degree than the polynomial in the denominator. To find this slanted asymptote, you must divide the numerator by the denominator using either long division or synthetic division. These rational functions, in particular, they're really good for describing distance and speed time equations, or also modeling multi-person work problems. Next, what is a piecewise function? A piecewise function is a function that's defined on a sequence of intervals. A common example might be the absolute value. Now, an absolute value function is a function that contains an algebraic expression within absolute symbols. In other words, it might mean the distance from zero on the Lambert line. Its main characteristic, it holds a V shape, and obviously it is a piecewise function. So now, we use piecewise functions to describe situations in which a rule or relationship changes as the input value crosses certain boundaries. For example, we use it a lot in real life to calculate simple or compound interest rates or taxes. Now, with these terms explained, and now that we already understand these, we can go on and finish the problem.
Well, firstly, we're gonna start by solving our problem, which is this one. We're gonna try to get the y and x asymptotes. Firstly, we're gonna try to get the y asymptote, which is by dividing the bigger factors on the equation, which is gonna be x cubic and x quadratic. But because of this, we can't actually get it because this is bigger than this one. Like it's dividing like 1 by 0, which is impossible. So we're gonna get y equals nothing. Doesn't exist. Then we're gonna try to get the x asymptote, which we're gonna get it by factorizing the equation, which is gonna be, and this one is gonna be factorized like this. If we don't get a gap, we mostly get like two like x asymptotes. So firstly, these are our asymptotes. We just have to like substitute this one and this one, which is gonna be x equals 2, and here x equals minus 1. This is because I just pass it like this. We made it equal to 0, and here's the same, and we just pass it to the other side. So, well, now I'm gonna explain the domain in the intersections of x and y. So I'm just going to do a little representation of what our graph looks like for you to get a better understanding. So basically, our drawing is going to be like this. Beautiful drawing by me. And now we're going to find the intersections of x and y. Well, you can clearly see 0, but I'm just going to try to explain it better. It's just like substituting here 0, x 0, 0, 0, 0. It's gonna be 0. Y is gonna be 0. And if we go like this, 0. We're just gonna end up being at 0 anyways. So that said and done, we can move here and say that x is gonna be, well, the intersection of x is gonna be 0, 0, and the intersection of y it's gonna be 0, 0 also.
So here we have the same graphic and same equation, but this time using a graphing software. And well, here is the equation, and you can see, well, here is the vertical asymptote. Well, it will be right here, but you can't see it because this program doesn't show it. And well, there's no horizontal asymptote, and that's because of the rule that if this power is greater than this one, that means that there's no horizontal asymptote. And well, the intersections, well, here we can see both of them, and it's in 0, right? In 0. And well, here we can see more about the behaviors and well, the domain and the range that we spoke about it. That we have spoken about it. Well, that's all.
And now I'm going to explain you basically how the domain will be, how it will look like. Now, because we have this here, we have the 2 points of intersection that are basically one over here and one over here. So the domain will be x that belongs to from minus infinite to minus 1, that is the nearest to minus infinite. Then we unite it, put in minus 1, and then 2, and then we unite it again so that we have 2 until infinite.
Understand and solve a rational function, which we really appreciate, and we also manage to understand the real applications that these might have.
We also analyzed all of its characteristics, like the domain range or the behaviors.
And we also learn how important they are and how we can use it actually in the real life.
Well, this function taught me like new things. Just because it doesn't have the y, like vertical asymptote, no, horizontal asymptote, doesn't mean like a graph can be graphed. So it showed me like new ways of how a graph and the symptoms can behave. And that's what we learned. So we want to say thank you and goodbye.